I'm Sarah Carter from Math Equals Love, and today I want to talk to you about how to solve pie battle puzzles. So pie battles are a fun seasonal pie day twist on the star battle puzzle. So star battle puzzles are a relatively new logic puzzle. They were introduced in 2003 at the World Puzzle Federation. And normally they involve placing stars in grids, but I thought, hey, Pie Day's coming up. Why don't we place pie symbols in grids? So let's talk about how to solve a pie battle puzzle. So the goal of a pie battle puzzle is to place pie symbols in the grid so that every row, every column, and every region contains exactly one pie symbol. So what do I mean by that? I mean, if I have a pie symbol here in this first row, then I can't have another pie symbol here in the first row. That would be two pie symbols in the same row. And I just need every row to have exactly one. Okay, so if I have a pie symbol here, well, this shape here also needs to have a pie symbol, because remember, we need a pie symbol in every row, every column, and every region. So if I put a pie symbol here, these two are automatically knocked out, so my other pie symbol would need to go here. Now, this is not the solution, and let's talk about why. The why comes from looking at this second line of the instructions. The pie symbols may not touch one another, either horizontally, vertically, or diagonally. So let's look at what that means. If I have a pie symbol here in this square, I can't have any other pie symbols touching it. So I can't have things touching it horizontally. So those two squares are out. I can't have pie symbols touching it vertically. Those two squares are out. And I can't have anything touching it diagonally. So these four squares are out. Now you'll notice this presents a problem, because if I put a pie symbol here and all these squares are ruled out, this region is left out. Okay, this region would have no pie symbol. If I put a pie symbol in one of the squares of this region, I would be violating the second rule. So if you look here, this is what a proper solution looks like. So if you're wondering, how do you check your work once you've solved the pie battle puzzle? Well, you check, does every row have a pie symbol? Does every column have a pie symbol? Does every region have a pie symbol? And then you're kind of thinking, can I draw a box around each pie symbol? And there should be nothing in that box. Okay, if one of them were to lie on the line of the box, then they would be touching horizontally, vertically, or diagonally. So for the pie battle puzzles I provided you, there are 5x5 puzzles all the way up to 12x12. And I'll tell you, the larger the grid, the greater the difficulty. Okay, so if you're working with young students, I would definitely be starting with the 5x5, 6x6. Hey, even if you're working with older students, it took me a little while myself to wrap my mind around the logic required for these puzzles. Let's see if we can solve a 5x5 pie battle puzzle by ourselves. One of the first things that stands out to me when I look at this puzzle is this little rectangle right here. It's only got two squares, so I've just got to figure out which one of these squares has the pie symbol. Now your students might want to just throw a pie symbol in one of the squares and see what happens. And on a smaller 5x5 puzzle, you might get away with that. But let's see if we can logic it out. So I know one of these squares is going to be the pie symbol. So let's just drag this little pie symbol over here, and we'll make them straddle the line. So we know one of these is going to be the pie symbol. I don't know if it's the top or the bottom. Well, if one of these is a pie symbol, I know that I can only have one pie symbol in every column. So if one of these is the pie symbol, then here, here, and here are not allowed to be pie symbols, because then I would have two pie symbols in the same column. Now, down here, I used to have this L shape, but when I've knocked out these two, now I'm just left with another rectangle. So I know in this rectangle, one of these has to be my pie symbol. So let's grab another rectangle, another pie symbol, and we'll drag him to this line. I know one of these is going to be a pie symbol. And since there's one pie symbol in every row, every column, and every shape, then if I've got a pi symbol here and one of these two, then these two cannot be pi symbols because that would make multiple pi symbols in the same row. Now, let's take a look here. This pi symbol is in one of these two shapes. Okay? If the pi symbol was here, then here, so if the pi symbol was here, then this square, and this square would be out. Okay? So if the pi symbol was here, then this square, and this square will be out. So what did you notice about those two? No matter where I put this pi symbol in either of these two squares, this one and this one are both either vertical or diagonal to it. So neither one of these can be the pi symbol. And look at that. We've got this, used to be, I like to think of that as a backwards Oklahoma since I live in Oklahoma. It used to be a kind of funky looking shape, but now we know the only two options for a pi symbol in this shape are here and here. So in this row, one of these is going to be a pi symbol. Let's drag it over. I don't know where, but one of these is a pi symbol. So in this row, these two cannot be it because they would be in the same row. And remember that logic we used down here for this? Both of these were knocked out. Well, I've got the same thing happening here. If I'm here, then no matter whether I put the pi symbol here or here, these two are not valid moves. Similarly, let's look over here. If I've got a pi symbol here, these two, whether it goes in the top square or the bottom square, both of these are either horizontal or diagonal. So this one's also out. Okay. Where can we go next? Well, if one of these is a pi symbol and one of these is a pi symbol, what do we know about this square? Well, I know that if I put a pi symbol here and I put a pi symbol here, that one can't be it, or vice versa. If I put my pi symbol here and here, that one can't be it. So no matter which combination I go with, this one is also out. Okay. Now comes the fun part. What do we know? Do you see it? Have you seen it yet? Let's look at this second row from the bottom. I know this row has to have a pi symbol. Okay, where does it have to go? Well, the pi symbol here is going to have to go in one of these two spots. So let's drag our little pi symbol over. So we've got a pi symbol in this region, a pi symbol in this region, a pi symbol in this region, and a pi symbol in this region. So that means this guy right here, we've already got a pi symbol in this region. This one's out. So I know one of these three symbols here belongs to my last pi symbol. I don't know where he goes in there though. Okay, so which columns have pi symbols? Which columns don't have pi symbols? Where do we go? Well, I like to play a game called What If. When I get stuck, I just don't know what to do. I just sometimes take a pi symbol and put it somewhere and see what happens. So I'm going to put my pi symbol right here. What if I put a pi symbol right here? If I put a pi symbol right here, then this one would touch it diagonally and it would be out. Let's change colors. Let's play What If in a different color. So my marks I know for sure aren't blue. Let's play What If with No, let's do green. So if I put a pi symbol right here, then this one would be diagonal, so it would be out. So that would make this one the pi symbol. And this one would touch it diagonally, so that one would be out. And this one would be the pi symbol. And then look what happens. I now have two pi symbols in the same column. So when I played what if, I've learned that this one is not a pi symbol. So we have found that this pi symbol right here goes here. Let's erase here. Okay, so if this is my pi symbol, the entire rest of that row is canceled. The entire rest of this column is canceled. I've got one square left in this top region. So let's grab our pi symbol, bring them over. Now we've got a pi symbol in the top row. So this can't be the pi symbol. So this pi symbol here moves down. The pi symbols aren't allowed to touch diagonally. So if I have a pi symbol here, then anything in the square surrounding it is out, which means this square right here is out, which means we can take this pi symbol right here, move it over. Now, anything in this column is out because this pi symbol already takes place in that column. So that means we're out here. Which means our last pi symbol goes here. Let's erase this and clean it up so we can study our answer and make sure that it is a proper solution. Do we have a pi symbol in every row? Row 1, check. Row 2, check. Row 3, check. Row 4, check. Row 5, check. Do I have a pi symbol in every column? Yes, I do. And do no pi symbols touch? I could draw a box around each one. And those boxes are not intersecting any pi symbols, so we are good. We have successfully solved a 5x5 pi battle puzzle. I thought about going to a 6x6, but no, I thought let's really take it up a notch. Okay, we're gonna go a bit faster on this one because we've already unlocked some of the logic. So I always like to start with the smallest regions first. I know one of these has to be a pi symbol. So if one of these is the pi symbol, everything else in the top row of the puzzle is out. And I know if one of these is a pi symbol, then the two squares below it are either going to be vertical or diagonal. So these two are out. So that's everything I know about that blue region. I see another small rectangle over here. Let's look at this rectangle here. I know one of these is going to have to be a pi symbol. Let's drag one in. So if one of these is a pi symbol, then that column is taken care of. So let's mark out the rest of that column. And then these two squares will either be horizontal diagonal, so they're out. And these two squares are either horizontal diagonal, so they're out. And then look at that. We have just found our first home, definite home for a pi symbol. This region right here only has one spot left. So let's take this pi symbol and move them in. We have found one definite location for a pi symbol. Now, as soon as you put in a pi symbol, you can eliminate everything in that column, everything in that row, and everything surrounding it that would touch it vertically diagonally. So I can draw my square here. And notice the square here goes into this pink region. And I've just discovered that this here cannot be the pi symbol. So let's mark that out. So in my pink region, I have now discovered that the pi symbol must be this lower piece. And then we're just going to continue. We've placed the pi symbol. So once I've placed the pi symbol, I'm going to eliminate everything in that row. The column was already eliminated. Okay. Everything in the row, everything in the column, and everything that would be touching it horizontally, vertically, or diagonally. So everything in the square can be eliminated. Now, most of those were already eliminated, but this corner square here can be added to my elimination list. Well, it didn't start off as a rectangle, but with all my eliminations, I've got myself a new rectangle down here. So I know one of these has to be the pi symbol. Which one? I don't know. Let's try a pi symbol. We know a pi symbol goes somewhere in that green. So that means the bottom row is taken care of. So this bottom row is taken care of, which means this cannot be the pi symbol. Otherwise, there'd be two pi symbols in the bottom row, which, if I look over here, I've got one lone square left in this region. So this has to be a pi symbol. Okay, I feel like the 7x7 puzzle is going faster than our 5x5. Okay, I've placed the pi symbol, so I'm going to eliminate everything in that column, everything in that row, and then everything surrounding it. But those are already eliminated. Okay. Where to now? I know the first row is here. I know the second row is either here or here. I know the third row is either here or here. That didn't help me. What if I look at columns? The first column is taken care of. The second column is either here or here. That doesn't help me. The third column is either here or here. That also doesn't help me. The fourth column, here or here, also not helpful. Look at it. In the fifth column, the only eligible spaces in the fifth column are these two spaces right here. So I know one of these has to be my pi symbol. Don't know which one. But if these two spaces are one of them is a pi symbol, that means this one would be touching either horizontally or diagonally, no matter which one I pick. So one of these is a pi symbol. One of these is a pi symbol. Well, look at that. Look at column number 4 now. It's either here or here. Okay. Let's think about this. I've still got two options. Well, I can mark out this square right here. So I can mark out this square right here. I don't know why I didn't mark that earlier, because it's in the same row as this pi symbol and the same column as this pi symbol, and it's diagonal to this pi symbol. I really should have marked that one out. Okay. Where's my last pi buddy got to go? Well, which region doesn't have a pi? That would be this region right here. One of these is going to be a pi symbol. Let's drag them over there. Maybe that will make things more obvious. So one of these has to be my pi symbol. Okay, we might be stuck playing the little game I like to call What If? I know I have a blank square here. Can I have anything in the blank square? Let's think about this. If I looked at this column, this one had to be a pi, which puts one in this region. So this one is out. Okay. I'm a bit stumped. That's okay. That's what makes this fun. Let's play What If. Okay. So for my what if, I'm going to mark things in black. I notice these two pieces are touching at a corner, and I think that might be the clue to unlocking them. I'm going to play what if, and I'm going to put a pie here, because I feel like this touching in a corner is going to cause an issue. So if I put a pie here, so I'm going to write myself a little note. I'm testing. This is my test. If I go a pie here, then these two are touching diagonally, which means this one is out, which means this one has to be my pie. And then I know one of these has to be a pie, but now I've got two pies in the same row. So I've kind of done a proof by contradiction, I guess, because I tried it here and then all of a sudden the puzzle fell apart and I had two pies in the same row. So what that tells me is the pie symbol cannot go in my test location. So this test failed. So the pie symbol must be here. And then I think the rest of the puzzle is going to fall into place. So this is out because it's the same row. This is out because it's the same column. And this is out, so it's the same column, which takes this little pie symbol and moves him over. And then I eliminate the row and the column. So now if I look at the pink, this pie symbol has to be here. And this pie symbol has to be here. So eliminate, place hints to yourself, clues to yourself. Sometimes you have to play a bit of what if. The harder the puzzle, the bigger the grid size. I should say that backwards. The bigger the grid size, definitely the harder the puzzle. So I hope you enjoy trying these pie battle puzzles out for yourself or with students. I definitely recommend with all logic puzzles to always try solving it yourself, because you'll learn some logical tricks and hacks and approaches that you can use when your students are stuck. I'll say I've spent many an hour solving these puzzles myself, and I've found them to be greatly enjoyable. So I hope you and your students enjoy this on Pi Day or any time of year, because you can always make time for more math. Happy puzzling!